Y28 hydrogen atom. Observe the fact is that first of all, hydrogen atom is a bound state of an electron and a proton. The simplest bound state created by the Coulomb force. In experiment, they have observed exactly four line spectrum. It is not continuous. It is not a rainbow. It is just four discrete energy levels. There's four wavelengths in the visible spectrum. Sure, there are additional waves with different wavelengths, but it cannot be seen with our bare eyes. By the time classical mechanics was completed and Maxwell's theory was completed, however, there was a problem. If we applied Maxwell's theory, electrons are accelerating. Accelerating electron must radiate electromagnetic energy. If it radiates electromagnetic energy, it must slow down. If the electron slows down, it must fall down to the proton. If hydrogen decays, the world, our nature must decay because everything consists of electrons and protons and neutrons. It's nonsense. That doesn't happen. What's wrong with the classical mechanics and classical electromagnetism? It was a fact. And Niels Bohr introduced a very interesting, remarkable idea that's completely wrong, but he explained remarkably, accurately these spectrums with a very stupid idea. So very stupid, on the other hand, a very clever idea. And nobody uses Bohr's theory anymore. However, he made a big step to explain hydrogen atom. And finally, it was quantum mechanics. Just what we learned is the Schrödinger equation. Pauli solved the Schrödinger equation and found exact solution that agrees with the experiments exactly. Elementary idea of Bohr is not a quantum mechanics, is a mixture of a quantum idea and classical mechanics. Electron, in quantum mechanics, electron does not follow the circular track. However, he was brave enough, Bohr introduced a circular orbit and introduced Coulomb force must be the same as a centripetal force, and anyone in this class can compute this. And he introduced an assumption that orbital angular momentum is quantized. If all the orbital angular momentum is quantized, something like we can draw a wave. This wave is defined uniquely. So if you make a single turn, you can return the same wave function, something like that. He introduced remarkable assumption, and solving this equation immediately find a constant. Now we call it Bohr radius, multiplied by integer squared. However, if you use this one to find the kinetic energy and potential energy, we can compute the total mechanical energy that is always negative. That exactly matches with the four line spectrum of the hydrogen atom. And this is called the fine structure constant. It's a pure number. It is approximately 1 over 137. Rydberg constant is closely related to the wavelengths of the hydrogen atom radiation. By the way, this is a remarkably agree with the experiments. It is not quantum mechanics. It is a just toy model. One must solve this Schrödinger equation, and Wolfgang Pauli is the first one who solved this equation. His solution gives the energy is the same as what Bohr has calculated. Orbital angular momentum squared is different from what Bohr postulated. The z component of orbital angular momentum, then if electron makes an motion, you have angular momentum. Because the electron has a negative charge, its magnetic moment is opposite to this angular momentum. Therefore, under magnetic field, external magnetic field, this hydrogen atom must feel the magnetic field energy. So this is a good measurable. In addition, in classical mechanics, there is no spin angular momentum. Spin angular momentum was found. The spin is what? Orbital angular momentum is created by actual orbital motion in space, circular motion or elliptic motion, whatever. However, if a particle stops moving, then orbital angular momentum must vanish. Then the corresponding magnetic moment vanishes. However, even if an electron doesn't move at all, it still has its own magnetic moment. So it is a magnet. Electron itself is an electric charge. In addition, it is a tiny, tiny magnet. There is no current at all because electron is not moving. However, it produces a magnetic field. This is found by Pauli theoretically and compared with the experiment. This is called spin. And spin does not have any corresponding physical value in Newtonian mechanics. The quantum mechanics created a new physical measurable that is a spin. And because it is a magnet, it has a z component, and these are all available quantum numbers of a hydrogen atom. Principal quantum number, orbital angular momentum quantum number, and magnetic quantum number determines the wave function of a hydrogen atom. And hydrogen atom's wave function can be factorized into two pieces. Angle that depends on the polar angle theta and azimuthal angle phi, and this is a radial wave function. Radial part is always separable as a factorized form. However, theta and phi they are mixed operator. Their derivative operators are mixed, and we cannot, in general, we cannot separate them. There is a, this one must be -1 instead of 0. Wave function must be 1. However, we can use the different wave functions with different quantum numbers. In that case, our result must vanish. This one survives, and it is a 1 only if every quantum number must be the same. Because the wave function is factorized into 2 pieces, sure, there exists a spin wave function that is ignored in here. That should be multiplied later, and that is independent of r, theta, and phi. Radial part integral is this, and this we can see L must be the same. Orbital angular momentum quantum number should always be the same. And this principal quantum number does not have to be the same, but if they are different, it is 0. Only if both of them are the same, it gives 1. Okay. Angular integral, this is not 0, from -1 to +1, cosine and phi azimuthal angle. They may be different. If they are different, they are all orthogonal. It will give 0, and only if orbital angular momentum quantum number and the magnetic quantum number, both of them are the same, they become 1. Okay, explicit form of the radial wave function is given in here. I don't want you to derive everything. It is a very difficult one, but if you are interested in, I have derived everything in these notes, and you can refer to this. An explicit form of the radial wave function can be found like that. Let me draw a figure. As you can see, radial wave function gives distribution. So if you square this and multiply it by r squared, it gives a probability of finding an electron. It's constant. This state is the ground state, and this will average will give the Bohr radius. Actually, explicit, it is in this note, I have evaluated all possible cases, and it is given like that. I did not copy the Pauli's calculation. I followed the Pauli's calculation, recovered, reproduced everything. You will find it. So it is exact calculation. This is calculation of this integral. Bohr did not evaluate this integral. Bohr introduced just a strange idea that orbital angular momentum is quantized, but that value is completely wrong. But however, by accident, the result was agreed with this. The spherical harmonics is the theta phi dependence of the wave function, and it has eigenvalues for the orbital angular momentum squared, that is L plus 1, that runs from an z component will give this. And explicit form is also driven in these nodes. Even if you're interested in, you can derive everything following these nodes. And especially special values for L equals to 0 is called S wave. S wave means it is independent of direction, so invariant on the rotation. We do not find any theta phi dependence in the leading piece, Y00. P wave is called orbital angular momentum quantum number is 1. if the P wave theta phi dependence begins, and D wave is L equals 2 sine cosine, this sinusoidal function square appears in the D wave, sinusoidal function's linear term appears in the P wave, no sinusoidal function or exponential appears in the S wave. It is impossible for me to draw the complex valued wave function. Instead, I can draw the only projecting out the real part of wave function. You can see it is a rotationally symmetric, and you can see the color. There is some dependence of the polar angle or azimuthal angle. And if you increase the orbital angular momentum quantum number higher and higher, complicated angular dependence appears in very strange form. And I have listed some history of finding the spin. And actually, this person seems to be comparable to the people who really found the concept of the spin. However, Pauli discouraged him, and then finally he proved the existence of spin, and especially for the spin statistics theorem. In nature, our matter composed of fermion and boson, and any particle has its own intrinsic spin that is either an integer or a half integer. Electron is a half integer, 1/2, and there are many other particles of higher spin. Boson, 0, Higgs boson, and any gauge boson, just like the photon or WZ and gluon, they are all spin 1 gauge bosons. And the matter in nature consists of bosons and fermions. And fermion has a special nature that the multiple fermion system has a complete anti-symmetric nature. Pauli's exclusion principle is the consequence of the fact that multiple fermion system must have a quantum mechanical wave function which is completely anti-symmetric on the exchange of identical fermion. Okay. Using this Pauli's exclusion principle, he counted the total allowed states for the electron, and he found that there are factor of 2 difference with the physically allowed state using using this wave function. He was not able to explain the nature. He made a mistake by a factor of 2. That means there are 2 allowed states for every NLM. Spin up and spin down, 2 states are allowed for an electron, and any 2 electrons does not have a symmetric state. That means 2 electron system does not have a spin up up or down down, because the wave function must be anti-symmetric. However, if we consider the whole system of wave function, including spin and orbital, this is spherical harmonics and the radial wave function, is a complicated business, and he was successful to reproduce the counting the number of states. Finally, this is the basis of a quantum mechanical understanding of a periodic table. Therefore, now the allowed state is 2n squared rather than n squared due to the existence of spin and Pauli's exclusion principle that the any identical fermion system must have completely anti-symmetric wave function under exchange of that identical particles. So you can follow, uh, read it through the basic nature of periodic table understood uh, in quantum mechanical way. Okay, that's it for today, and that's it for this semester. Thank you very much for listening.